Part 1, Linux. Alright, in this nugget is where the fun begins. We start talking about exploits. Isn't that a lot of fun? One of the things we talk about with exploits is the buffer overflow. Now, buffer overflow is a way that we can take advantage of certain exploits for proof of concept, and that's where we'll use our O-day, our exploited code, or our lines of code, or whatever it is, to compromise a system. And one of the ways we can compromise those systems is also by installing Trojans. Now, fortunately, we don't really have to do much with that. Maybe we just email somebody a program or a link or something like that, so that the unsuspecting person launches a Trojan, which typically gives us rootkit access to their system, which means that we pretty much can do whatever we want to on that system. Then I'm also going to conclude this section with Linux demos on how to do things such as take over remote systems. Well, in this nugget, as we get started into rootkits and Trojans and backdoors and things like that, various types of exploits, one of the things to understand is that a lot of this really gets started as something called a buffer overflow. Because you see, we don't have administrator or root access to a lot of our targets, and we want to install applications on many of them. Well, you got to be an administrator for that, or root. Well, other things, we want to change some services. Well, once again, got to be administrator or root. Well, how are we going to get to that level if we're not already there? Well, we talked in a recent nugget about password sniffing and password cracking. That's one way of getting that done. And if you can't copy the shadow file because you're not the local root administrator, another thing you could do is you could sniff the traffic off the wire and pick hashes off the wire. That can be done with Loftcrack, which I showed you last time as well. So there are ways of still getting some kind of administrator or root access. But apart from that, you can also use something called buffer overflows. Now, here we spill over a little bit into something that's outside of the realm of certified ethical hacker. This is a little bit more of a shell coder or a programmer, because they need to be able to write code that takes advantage of these things. But as a certified ethical hacker, hey, I really have no interest in writing code. It drives me nuts. It gives me a headache to look at it. So I'd rather just someone else wrote it. And usually other hackers, especially once it's no longer O-day and it's become known, they're usually willing to share it and post it on websites, and I can use their little snippets of code or script or whatever to suit my purposes. But in any case, these buffer overflows is the basis for a lot of different attacks that can be launched against your targets. Using a buffer overflow, for example, you can plant a Trojan on a destination computer. Now, as soon as I say that, I also say that, Trojans by nature are designed to be something that people willingly launch because it looks like it's a game or something. Oh, it's a game. I'll double-click on that. Or it looks like something, a piece of software that they want to go ahead and launch. So that's not directly tied to buffer overflows. But it can be, because it can escalate privilege, and it can do so by doing a buffer overflow. Then there's also viruses and worms and things like that that can be transmitted, or that can be viruses that can be transmitted, stuff that can be launched as a result of a buffer overflow. Well, let's go ahead and take a look at what a buffer overflow really is. We've heard of that probably in the past. We might have also heard the term stack overflow, which is kind of a subset of a buffer overflow. Really, the bottom line of it is that you're stuffing too much memory in a limited amount of space. Let's take a look at an example of how that might work. Let's say that this rectangle here represents 512 bytes worth of data. And that's what just a normal application is using. It could be Notepad. It could be something with system privileges. And that's typically what you want to work a buffer overflow against, because if you're just generic user, but you launch an application that will be able to work with this memory space where the system owns it, then what could happen then is that we can shove out something that's already in there, and it just kind of spills off the end over here. This could be something that's also valuable, by the way, like we had with pwdump2 in our last nugget, and that was the password hashes that it spit out the end of there. Well, now what we've done here is we've injected our own process into that, and as a result, our process, whatever it is running under system privilege. So even though the logged on user might even be just a guest account, or just a generic user with no special privileges whatsoever, once we stick our own little application in here, we're running under the system account, and from within this, we can then launch additional applications as well of our choosing. And this is probably an oversimplification, but that's the basic idea of how this works. Now, another thing about buffer overflows is that it requires some kind of an exploit. I mean, if you were just kind of a beginning programmer of some kind, you could write something that would do a buffer overflow on some little application, but what would that do? What would that get you? In many cases, it'll just cause the application to crash. or you'll get one of those, not responding little dialog boxes that we get within Windows a lot, where you have to click on End Now. Or it could simply do a denial of service attack, where the whole system stops responding or a service stops responding. Sometimes that's actually good if you want to do a denial of service attack against a system. But what we really like with buffer overflows is to replace it with some kind of an application that we can really use on the other end, so that we can get some good vulnerabilities out of it. Well, with this exploit, one thing you'll want to do is you want to do your homework in advance. First of all, remember, early in our whole series here, we've talked about intelligence gathering, and we talked about social engineering, network reconnaissance, service identification, scanning destination networks using Nmap and things like this. Well, do your homework in advance so that once you've scanned that network, you know what ports are available. Once you identify the ports, you have some idea of what services are running. Then you can tell that and confirm what services really are running. Just make sure you don't get any false positives. Then once you do that, you also are able to identify operating systems, applications that are in play, and possibly also which patch levels are in place there as well. Now, once you put together that kind of information, you know something about the operating system, the applications, and patch levels, then I put together some vulnerability kind of websites here where you can just kind of get a list of all the different things where you can search for different types of vulnerabilities here. And this just gives you a number of different vulnerabilities against Cisco, for example, or against various versions of Linux. And, of course, Microsoft is obviously going to be in here somewhere. And this is, I like this website because it's kind of a conglomeration of a number of different websites as well. So it kind of puts it all in a one-size-fits-all location. Other things you could do is go to this Get Common Vulnerabilities and Exposures, and you can download an entire list of different kinds of vulnerabilities as well. So identify what your vulnerability is, and then you can move forward from there. Now, this is just kind of a miscellaneous comment here as it relates to this stack overflow and buffer overflows that I talked about earlier. For Windows operating systems, you need at least 700 bytes of memory space to work with, of buffer space to work with there. That's actually quite a lot of memory. Application developers are forced by marketing to want to get their applications into as little bit of memory as possible, because when people buy software and they look at the side of that box and it says, geez, it needs 512 megabytes of RAM? No way. So they try to trim that down over and over and over again as much as possible. But because of something called boundary checking, if the application developers do not do boundary checking on all parts of their applications, there might be some that don't specify where this has to stop so that it won't allow you to shoot data out the end of this thing. It'll just block it right here if bounds checking has been done properly. Might still cause other problems, but it should not allow that kind of thing to happen. And that's where a lot of these exploits come from, is where some programmer has gone through lines and lines of code, or they try to decompile as much as they can, and they try to find spots where there hasn't been any bounds checking or where there's been a little bit of sloppy programming done there. And this is especially another reason why Microsoft products can be vulnerable. I mean, I don't know how many lines of code are in Windows 2003, but I do remember for Windows 2000, there were over 40 million lines of code. I mean, it's just virtually impossible to go through the whole thing for even teams of people to go through it and find every possible vulnerability there. So us hackers do it for them. It's a service that we provide for free. But anyway, getting back to what I was saying here, the reason why 700 bytes is key is because we need at least that much in order to launch a command shell, command.exe, if I can make an X, a command.exe. And if once we do that, then we'll be able to usually launch that under system privileges, and you can do anything you want from a command line on that destination machine. And we're going to take a look at an example of that a little bit later on here. If you can't get 700 bytes, well, sometimes that's just the way it goes. If that's the case, you're still a pretty good chance of being able to launch a denial of service attack. Because when you inject something into this portion of buffer memory and you do a buffer overflow, it probably causes that service or that application or whatever it is that's using this memory to hang or to fail or to otherwise not perform properly. Now, Linux, on the other hand, and this goes with the roots of Linux, this is where Linus Torvalds decided that he wanted a lean, mean operating system that you could fit on a floppy disk. He didn't want to use a whole ton of memory to get a lot of these things done. Well, that's starting to change with Linux. The last version of Linux I installed took almost 5 gigabytes. Of course, I added a bunch of stuff, but still. In any case, you can use about 24 bytes worth of memory there to fiddle around with. So there's a lot of more room to play with Linux operating systems. Now, there's also Trojans, and this is another kind of a code that a hacker can use to great advantage to take control of a destination computer. A Trojan is undesirable code inside or masquerading as desirable code. And that's my own definition. I kind of distilled down a whole bunch of different ones that are out there. But that's the idea. It looks like something I want. For example, a friend sends you a game, and so you download this game, or you get it in an email attachment, you save it to your hard drive, and you double-click on the executable. And maybe it's one of those games like Whack-A-Mole. Have you ever seen that? It's a little computer game where you can take a little mallet and use your mouse to control the mallet. And every time you click, it hits one of the little moles on the head. And, it's just kind of entertaining for about 2 minutes. Well, 9 times out of 10, when you've played that game, guess what you've actually done? You've installed a utility called NetBus, or a Trojan horse called NetBus. This allows a hacker to pretty much have total control over your entire computer and file system. So once again, it looked like something that was desirable code. I wanted to play that game, but I didn't know that I also installed NetBus when I played that. And so again, it looks like something that you really want, but in the end, once you've realized what's really happened there, you're filled with a bitter bile of regret. Kind of a lot like marriage, actually. No, I shouldn't say that. I have a wonderful wife, and plus I think she can hear me in the other room. So anyway, moving right along here. What we have with this is we have a number of different things that can take place. It could be a keylogger. It could keep track of everything that you're typing in. It could snatch your passwords. Also, here's the big part of Trojans, is the remote access. This is pretty much the eye on the prize if you really want to get a good Trojan on a destination system that you're targeting. If you can set it up so you can get remote access, you can pretty much control that computer anytime you want. You can copy over other backdoor applications that you can leave on there, so that even if they find your Trojan that you've installed and uninstall it, or they have virus software that uninstalls it or something, you leave a backdoor program in there that just kind of sleeps until you wake it up. Oh, that's one reason why we really like that remote access. Always leave yourself a back door as soon as you compromise a machine. Also, what we can work with these Trojans is that they are delivered in a number of different ways. Email is probably one of the most common ways. Really watch those email attachments. Now, yes, a lot of antivirus software will detect those attachments and say, oh, you got some kind of a virus or some kind of a Trojan located inside of this email, won't allow you to run it, or it'll quarantine it or delete it. Well, great. The problem is there's a lot of programs out there that will allow you to wrap a Trojan inside of what's known to the applications as a good application, or at the very least, a harmless application. In fact, what you could do is you could say, hey, here's a really neat new graphics utility, and send it to somebody. And it might just be Paint, the normal Paint program that you get with Windows. But what you can do is you can use a wrapper program that inside of Paint there will also associate along with it an additional executable, so that as soon as they double-click on paint.exe, it also launches this malicious application, or this Trojan of some kind. So that's one way you can get it, is through email. Another way you can get it is through malicious websites. Somebody that has put up a website out there on the internet, and it might be a combination of two things. They send you an email link to their website. As soon as you click on it, it unleashes some kind of a malicious ActiveX control or something like that. And most users just click on yes, and anytime they see a dialog box. Do you want to run this application? Yes. Do you want me to crash your system? Yes. Do you want me to infect your computer with all kinds of Trojans and viruses and spyware? Yes. It doesn't matter what the dialog box says. They'll click yes no matter what. So, and again with games, that's a lot of the times how these Trojans are installed. Now let's talk about a few well-known Trojans here. First of all, Netcat. This is something that we still use a lot, and this is something that you can use to remotely control a destination computer, primarily because you can use it to launch a command prompt. And again, once you get the command prompt, as long as you know your command line interface and your command line tools, you can pretty much do whatever you want to on that destination computer. The other thing you could use is CryptCat, which encrypts the traffic, making it much more difficult for IDS, or intrusion detection software, to identify that you've installed one of these Trojans. Then there's Sub7, Back Orifice 2000, I just abbreviated that, BO2K, Back Orifice 2000, and NetBus. And these are all kind of obsolete, really. They work great if you're attacking Windows 95, but really, who needs a lot of skill to attack Windows 95 anyway? These were so 10 years ago, but they're still listed on the Certified Ethical Hacker exam objectives, so I kind of mentioned them here. But these are utilities that, again, would allow you to have total control with these. I remember I used to have a whole bunch of fun with NetBus. With NetBus, you could, from halfway around the globe, open and close someone's CD-ROM tray. and that really gets them confused, by the way. You could copy all of the files off their hard drive. You could delete all the files off the hard drive. You could do anything you want to with it. And Back Orifice 2000 had a similar kind of a thing as well. And then other people came out with ways of plugging them up and stopping them. For example, with Back Orifice 2000, if you'll forgive me, but someone came up with something called a butt plug that was supposed to have stopped Back Orifice 2000. There were also scams with this. And these are still going on. It's just that they're not as common as they used to be, and there's not as many targets that you can use because not as many people use Windows 95 and 98. But anyway, there was a Back Orifice 2000 cleanup utility. And it says, if you suspect you've been infected or if you don't ever want to be infected with Back Orifice 2000, launch this little utility, guaranteed to work. Well, what it actually did was it installed Back Orifice 2000 on a machine where there was no Back Orifice 2000 in the first place. So, you kind of shot yourself in the foot when you ran that one. Now, a lot of these Trojans are rootkits, and that's an example that I just gave you, NetBus, Back Orifice, and some of those others that we talked about. These are tools that are going to fully control the target, so I can do jolly well whatever I please over there. Again, like I said, they're often Trojans, but they do require installation somehow. And it's not an installation where it's all, next, finish, but I have to get the core files for that rootkit on my destination somehow. So we'll be taking a look a little bit at that as well. Now, you might have been able to do that because you sniffed network traffic, found a password hash, cracked the hash, were able to get a local logon, a number of different things like that, or some kind of an overflow attack, a buffer overflow attack. That's going to be one of the best ways so that you can at least launch a command prompt. As long as you can get to a command prompt, especially with Windows, it doesn't really matter what level of privilege the logged on user is. Because once you get to that command prompt, you can copy files from wherever you want to, from an FTP site, whatever you need to do, and that machine is pretty much yours as soon as you see cmd.exe. All right. Some of these rootkits are pretty much going to be impossible to find. They have ways of hiding themselves. I mean, you know how in Windows you can right-click on the taskbar and you can choose Task Manager, and you can go into Processes and Applications and you can see what's running, and you go to Processes and you can sort this by name and so forth, and you can see what's using a certain amount of memory and CPU utilization. Well, this should show me all the applications that are running, but there are a lot of applications that are able to conceal themselves and not show up in these processes at all. One reason for that is because they will often install themselves as a, whoops, if I can quit marking things up here, install themselves as a driver. Or in Linux, it's going to be a pluggable authentication module, or a PAM. Well, in Windows, if the drivers don't appear in that list, they do stuff, and they might, in certain ways, require CPU cycles and all that, but they don't appear in that list I just showed you. And so, if you can install a rootkit that looks like a driver and operates like a driver, it's very, very difficult to find and track down. Other things that can go on with rootkits is they might be files that replace what we would otherwise think of as known good files. For example, in Windows, somebody might replace the notepad.exe file with their own version of Notepad. And it might look and feel exactly like the Notepad that comes with Windows, but inside of it is also a Trojan or some other kind of malicious code. Also, you can change the path. And this is going to be the case when you don't want to actually replace the file. You want it to still be there. That way, if someone goes to the file that they're used to seeing there and they run a virus scan against that one file, then it doesn't come up as a virus. Yeah, they've still got Notepad in its original location. It's untouched. But what I might do, however, is to change the path statement on that Windows box, and therefore, whenever they type Notepad from a command line, then it immediately goes to my version of Notepad instead, because my path statement appears before the Windows system path statement. And this is also a known thing with Linux boxes. So if I'm in a Linux box here, for example, then I would just be able to identify what my path is. I'll just do a $path. And this shows me my normal path. If I'm typing a command from the command line, first searches user local sbin. If it's not there, then it goes to user local bin. Not there, then it goes to sbin. And then you see how this goes. Well, what I might do as a hacker is install my own item in the path ahead of all the rest of these, so that even though those good files are still there and untouched, it'll go ahead and use my version of the file instead first. All right, now some of you have been going through all these videos and just saying, James, come on, show me how to hack something, okay? Well, finally we're there. You have to lay your groundwork first, and that's why I've done all these videos up to this point. But from, this point on, we're going to show a few hacks every now and then that are really going to be, I think, interesting to you. Now, the first one I'm going to show you is an oldie but a goodie, and it comes from something called an SUID root attack. SUID is short for set user ID. Now, what this means is that any attribute can be set on a file on a Unix operating system, and it's going to run that application with the permissions of whoever it is that owns that particular application. So what we're going to do is we're going to take a look at a file. Remember, one of our files we looked at recently was the shadow file for passwords. Well, if I'm just logged on to my Unix box as generic user, and I don't really have root privileges, then how am I going to be able to access that shadow file? Because I mentioned that as a bit of a problem in one of our recent nuggets, that I can't really access that shadow file and crack the passwords there if I'm just a generic user, and if I'm logged on as root anyway, big deal. I already have access to it. Well, here I'm just going to go ahead and switch users to a different user account that's not a root account, and I'm going to show you how I can get root access to something regardless. All right, so here I'm just going to go ahead and log on as Bob, so I'm going to switch users to, not Bub, but Bob, and my password will expire soon. Okay, thank you very much. Now that I'm logged on here as Bob, let me just go ahead and do something. I'm going to launch this oldie but a goodie hack. There's an application called eFax. eFax allows you to specify which modem you want to send a fax through, and you do that by specifying a -D when you type in eFax. You'll see that here in a minute. Now, if I choose to specify a file instead of an actual modem, because I don't even have a modem attached to this computer, but if I just do something like eFax-D, and I say, I don't have a modem, but you know what? I really want to see what's inside of a certain file. How about that file called /etc shadow? Press enter. Wow, guess what? I get a lot of, warning, Will Robinson and all that kind of stuff. This is messages coming back from eFax saying, hey, this doesn't look like a modem. Now what do I do? Well, I know what this is, and this is something that I really want to have, because guess what? These are all my hashes for my various different users. So if I wanted to figure out what, Bob's password was right here, then I would just copy and paste his hash there, and then we could run that against, John the Ripper and get his password. Now, even if I compromise that root administrator's password, that root password, I'm not going to log on as the root account all the time anyway. I will if I have to get something done. But what I'd rather do is to install something like a keystroke logger, and that way I can keep track of any passwords that the user types in there. I can see what they're typing in their memos and their emails and all that kind of stuff. This is going to use something called vlogger, and it has both a server and a client piece. The server part of this is what's going to receive UDP packets containing the keystrokes from my victim computer here. Okay? All right, so let's go ahead and get started with that as well. And so here what I've done is I've gone to the user local directory and I've changed directories to vlogger-2.1.1 where I've installed that file. And again, you can just download this from a number of places on the internet. It's usually a tar.gz file. You got to do a .configure and then a make, and then it'll be ready for you to use. In any case, what you do to launch this is you just do a // in the directory where it appears, /vlog server. This is going to be the component that will receive the keystrokes from my victim. And then I'll enter in a unique port number. So, I want to enter in a port number that's not being used by any other applications or anything. Once I do that, then over UDP, it's going to listen on that port, and it's going to see if it can get any keystrokes from another system. Now this is actually going to be my victim computer here, where I'm going to go ahead and exploit this and try to capture some keystrokes. Now here I've gone to the victim computer, and you can also follow my tabs up here. .43, let me go back to that. This is my virtual machine where I've already got the server portion of this listening. .46, that's going to be my victim computer where I'm going to capture the keystrokes from. So I've already been able to crack passwords or something where I can interact with this system, and I'm going to go ahead and put my keystroke logger on here. So what I'll do then is I'll just type in actually I got to go to that directory as well, so I'll cd user local vlogger, and I've already installed it here as well. And then I'm going to go ahead and do a ./vlog config. Okay. when you do this, then it just takes you through a bunch of different prompts here. Do I want to continue after having agreed to not holding anybody legally liable for all the hacking that I'm about to do? Yes, I will promise I won't, hold you legally liable for that. And then I have to specify a magic password for the log mode switching, because there's a few different ways of logging the keystrokes, and I can switch that while in the midst of trying to capture the keystrokes. So I'll just put in a password here. How about you are hacked? You are hacked. All right, and press enter. And then choose a time zone. I really don't care. I'll just press enter. Choose a log method. We're going to do this over the network. It's not done locally, so it's going to be done over the network. And then I need to choose a default log mode. 0 is no log, 1 is dumb, and 2 is smart. Well, the indication there would be, I'm just going to go with the smart one, right? I don't want to be dumb. But in reality, dumb only means capturing everything that the person types. Smart means that it will just try to determine what passwords are being typed in. So it'll only give me things like usernames and passwords and other sensitive information like that. And then I can enter in a fake source IP address. The usefulness of this is it can help me to fool intrusion detection systems. Also, I'll tell them that my IP address is 10.10.10.79, even though it's really not. This is what's going to be reported to IDS. Then I determine which port we're going to use. UDP port 53 is a good one because that's usually open even across firewalls because we have to be able to perform DNS queries. All right, then what's the vlogger server's IP address? That's 10.10.10.43, and I have to kind of identify that in the tab up there. That's the .43 system up there. So I enter that IP address in, and then I enter in the destination port. Oops, what port did I give it? I already forgot. Go back. 5005. How can I forget that? Okay, so it was port 5005, and press enter. And then this is a very important item to take note of. Auto hide vlogger module after loaded. Choose no, because if you say yes, then there will be very little way for you to ever remove this at a later point in time. It kind of locks you. It kind of paints you into a corner there. So I'll just say no there. That way I can manually unload this later on if I want to as well. Okay, that's pretty much it for getting this all ready. Now all I need to do is to actually run it. All right, so to get this thing rolling then, all I have to do is /vlog control load. Okay, and press enter. Now, if once you've typed that in, don't get absent-minded and accidentally type it in again and press enter. You know why? If you do, it'll be the last time you ever see this system alive. What it'll do is it'll cause permanent kernel failure and destroy your host. And so that's kind of a way of this whole thing just folding back on top of you. You're supposed to be the hacker, and now your system's unusable. So don't ever load it. Don't ever load it twice in a row. If you feel like there's a problem with it, then again, this time you'll go the same thing, but you'll do unload. Okay, so use that and then reload it again, but don't just load it twice in a row. All right, now we're about ready to get started here. So over here on this computer here, this is one of my servers. This is what's going to receive the keystrokes that I'm typing in over on this computer, right? Okay, so what we've done is we've already entered all that in. And then we're going to just exit out of that terminal server so nobody sees what we were typing here. And now, this person who's, logged on as root, he says, you know what, I need to create some accounts. So I'm going to go ahead and create some users and groups. And I got a new employee starting up that's going to work with sensitive human resources documents. So I'm going to add this user. That user's name is going to be, Robert. And his password is going to be, I'm not going to actually say because I don't want you to know. Okay, so then we'll go ahead and click OK down here, and I forgot. It's not supposed to have uppercase. All right, I'm used to Windows. All right, so we enter that in and with a really secret password, so nobody will ever know. And what do we have over here? Strange characters. Okay, I'll just be honest with you. As with many hackers' utilities, again, they're not really regression tested and everything, and this thing kind of crapped out on me a couple of times. So in any case, I'm trying it again here, and we'll see what happens. So let's say that now this person's in their console here, and they want to change directory to the top, and they're going to do a directory listing and, all these kinds of things. Let's see if these keystrokes that I've typed in here will get recorded over here. And sure enough, change directory, I wanted to list, what was in there. Maybe I wanted to change directory again. User local, and I want to go ahead and run an application. Let's see what we got in here. Maybe they wanted to run hping or something like that. And we could see if they type all of that, or if they create a user account from the command line here as well. We see that all of that is being recorded over here. Hopefully they'll enter in a password somewhere, and I'll be able to get a hold of that. Or if they do a SU, and they type SU to go into the root account and change things as a root. So again, this is one of those things that doesn't work 100% of the time, but it can get me a really nice password every now and then if I'm looking for one. And this, by the way, would also be especially useful because, remember, I can already get the shadow file, so I can crack against the passwords. But if some of those are extremely complex or long or something like that, and it's taking John the Ripper way too long to crack it, well, it's much easier to just snatch it out of the air when the person types it in, and I'll receive it on this end. Or if they're trying to connect to a website that they have membership access to, and I want to have to steal those credentials, or they're logging into a system that's on a destination machine that they wouldn't have hash passwords for on their local machine in their shadows file, then again, another way for me to get those credentials as well by using this keystroke logger. All right, now let's do just about the mother lode of all hacks for Linux. What we want to do here is I want to be able to use a password of my choice to log into any user account. If I want to log on to Bob's user account, I don't care what his password is. I'll type in my password and still get in. This is using something called a backdoor. What we're going to do is to deploy a malicious PAM, or a malicious pluggable authentication module, because remember that this is the kind of thing that gives Linux the possibility for being able to have additional types of login. I mean, typically, it's going to be the login service that uses a check against our hash for our passwords. That's why we enter in a username and password. But with something like a PAM, we can have a biometric device. So, I don't know, an iris scanner, a fingerprint scanner, any other kind, maybe smart cards, any other kind of a logon besides just your typical username and password could be used. Now, if we have a malicious PAM, we're going to replace one of the PAMs that already appears in Linux, the good one, with our malicious PAM, and nobody will be the wiser. But the malicious PAM has also been secretly changed so that it includes only a kind of a God password, so to speak. And with this password, we'll be able to log into anybody's account. So let me get right to it. Here we have, I've got this file, pam_unix.so. So I'm just going to right-click here and copy it. You can, look for one of these on your own on the internet somewhere if you need. And I'm going to do now is to copy it over the top of the existing pam_unix.so. And I've already made a copy of this, by the way, just in case something blows up. And you see that it's located in the lib security directory. So now I'm going to right-click here, choose paste, overwrite that file, and close everything up here. Now the next thing I'm going to do here is just go ahead and log out. Okay, I'm logged in as root right now, but that's all right. It doesn't matter. I'm going to log out and log back in as, well, whoever I want to, actually. Now what I want to do is to go ahead and log in as, whichever account I want to log in as. And in this case, first of all, I need to stop the existing login service so that when it starts back up again, it reads from that pam_unix.so file that I pasted in there. Now, first of all, before I do that, what was the secret sauce with that pam_unix.so file that I put back in there, that I replaced? Well, it adds 4 simple lines that just about any monkey could type from the keyboard. And in those 4 simple lines, you just enter in the password that you want to be able to use regardless of who it is that's logging on. In my case, for example, right now, first of all, I need to go ahead and do a PSA to find the login process, which is process 1884. So I'm going to kill that. Remember, we talked about kill way early in our whole series here when we were talking about Linux. And what was the number again? 1884. So I'm going to kill that process. Then it starts the logon process over again. It automatically regenerates that login. But now it's read from the new file that we used. So when we say login here, who I want to log in is root. And what's root's password? I just entered in a secret password that only I know. It's not the password that's actually associated with root in the hash, but nevertheless, I logged on with it anyway. So, and I'm asking you to just take my word for that, because there's no way you can see what I'm typing anyway. But I just entered in whatever password I wanted to. This is now a totally backdoored system. Now, I could log out and log in using the password that is associated with root. Now, those are the only two ways of logging on. I can't just enter in any password I want to. It has to be a password that matches what's been entered in the pam_unix.so file. That's one way. That's the backdoor way. Or I could log in with the legitimate root password. Either way gets me where I want to go. All right, so I did log on using the root account, and I used the backdoored password, and it's still logged on right now on my virtual machine. Now, a lot of administrators will say, well, yeah, but our systems are secure. We never log on with the plain text password. We only use SSH to log in remotely. Well, that's good. SSH is secure. It encrypts the transmissions, makes eavesdropping virtually impossible. It makes it almost impossible to perform any kind of a man-in-the-middle attack. It's really good. But when I hear people say things like that, oh no, on our servers we only use SSH, it still kind of makes me laugh because there's still ways around that. I'm going to use PuTTY right here, and this is just a Windows tool that you can use to SSH into a host. And I'm going to SSH into that host where I used the backdoor password. So what's it? 10.10.10.46. I'm just going to use all the default settings here. I'm going to go ahead and click Open. And then what we're going to do is it's going to ask us to log on as. Oh, okay, let's try this. How about root? And what's the password? Well, I don't really know what root's password is. I haven't really been keeping track. I don't really care because I have my backdoor password, which I type in right now. And there we go. Now, see, I'm now fully successfully logged on as root using an SSH session into this account and into this system. In this nugget, we discussed exploits, and boy, wasn't this fun. We started off with a discussion of buffer overflow, kind of the idea of how it works and how you can shove memory into a certain buffer and out of the other end of that buffer see something pop out that might be useful information, or we can also inject certain kinds of code into that buffer overflow and get some level of control over a system. And one of the things we can do with that control is to work with the Trojan. Now, this is actually something that you'll probably email somebody or trick somebody into clicking on in a link with a malicious web page. But once they've executed that, then it installs probably a rootkit on their system. And that gives us then full control over that system. One of the things we also want to do is to always use a backdoor. One of the things that I showed you in this Linux demo here at the end was a number of different things. I showed you how to install a keystroke logger and things, but the last thing we showed was certainly how to leave a backdoor there so that we really never have to care what the password is on any of the accounts. We can log on with any of them using kind of our super secret password that only we know. Well, I hope this has been informative for you, and I'd like to thank you for viewing.